Hey students, this is lesson 614, the distance formula. The distance formula is a formula that allows us to find how far apart any 2 points on the coordinate plane are, no matter where they're located. I'm going to do this part in class here, this page. I'm going to skip ahead to a couple pages. We're going to start right here. We'll do a couple of these problems using the distance formula. And let me introduce you to the distance formula by showing you just a quick little example on a graph. All right, so let's say we have any 2 points on this graph. Maybe we have a point like, say, right there, and maybe another point right there. And I want to know the distance between those. In other words, if I were to draw a line between those two, like this, how long is that line? Let's call that D for now. All right, and I can find that. One thing, if I can find that line by just creating a right triangle on the coordinate grid and using Pythagorean's theorem. So if I were to draw a line from there to there, and then from there over to there, I now have a right triangle. And I can find the length of the right triangle just by counting the grids. There's 1, 2, 3, 4, 5 here, so that length is 5. 1, 2, 3, that length is 3. And then I can use Pythagorean's theorem. I can do, I can say D is equal to, I want to do 5 squared plus 3 squared. And then whatever that equals, I take the square root of that, and I get the distance. And 5 squared is 25, 3 squared is 9. 25 plus 9 is 34. So D is the square root of 34, which is about 5.8. So that distance is about 5.8. But let's think about this for a moment. What we could do here is just use our coordinates to find those distances. What I'm saying is this: if we look at this point right here, and look where that is on the x-axis, that's at 4, which is given by that coordinate. And then the second point right here, that point is at 9 on the x-axis. Now think about that. How far apart are those two coordinates? And we can get that just by subtracting 9 minus 4. 9 minus 4 is 5. Likewise, we can use the y-coordinates, the 4, because we're at 4 right here on the y-axis there, and we're at 7 on the y-axis right there. And so those 2 points, the 7 and the 4, if we subtract those, we get the up and down distance of this triangle. 7 minus 4 is 3. Well, after we did that, we squared those numbers, and then we added those together. And once we had that total, we took the square root to get the distance. Now, in a more general sense, if I get rid of this whole graph here and delete all that and just make a more general graph, so I have my y-axis and my x-axis, and let's say I just have 2 points randomly anywhere on that. So let's just say right here. Then I have another point right there. And I want to find the distance between those 2 points. So how long is this line from there to there? We'll call that D. Well, once again, if I draw in, and I think I'll use a dotted line here, if I draw in a horizontal line and a vertical line, I have a right triangle. And the distance from here to here is the difference in the x-coordinates. So no matter what my x-coordinate is, and let's just call it x sub 1, and we'll call the distance up for this point y sub 1, and then we'll call this point my second x point, so x of 2, and my second y coordinate, y sub 2. Well, this distance from here to here, I get by subtracting the x coordinates. And so I can say x of 2 minus x of 1, or either way, because when I use the distance formula, I'm going to square it, and if it's a negative number and I square it, it's a positive number. So I can just call this, I'm subtracting my two x coordinates. Likewise, here I'm just subtracting my two y coordinates. So I can just say y sub 1 minus y sub 2. Then I add those together, and I take the square root, and that's my distance d. So that's the formula we're going to use, and I'll show you how to use it here. So let's go back to page, and let's write this distance formula right here, right now. So distance equals, I want to subtract my two x coordinates, and then square that, subtract my two y coordinates, and square that, and then add those two together, and take the square root of that. So let's try it here on number 6. So distance equals square root, and in the first parentheses, there's a squared there, and there's a second parentheses and a squared there. We are going to subtract 3 and the 6. Now, it doesn't really matter which way you subtract them. If you subtract 3 minus 6, you get negative 3. When you square that, you get positive 9. Or you can do 6 minus 3, and that's positive 3. And when you square that, you get positive 9. So it doesn't really matter. And now I'm going to subtract my other two coordinates. I can either do 1 minus negative 3 or negative 3 minus 1, however you want to look at that. Doesn't really matter. So now I'm going to just simplify this a little bit here. 6 minus 3 is 3. We're going to square that. Negative 3 minus 1 is negative 4. And I'm going to square that. Negative 3 squared is 9. Negative 4 squared is 16. And 9 plus 16 is 25. And the square root of 25 is 5. So the distance between these 2 points is 5. All right. We're going to do that in class tomorrow. We'll practice a little. If you want to try a couple more problems, go ahead. And I'll talk to you tomorrow.